Hi everyone, my name is Zharkova. I'm lead mobile developer in tech software company. Today I would like to present a talk about new framework SwiftUI and how it could be used with existing application, what should be done in existing application to adapt logic to using with new framework. And today we will talk of course, about SwiftUI and its conception of the declarative SwiftUI. We will talk about the specifics of data flow in SwiftUI, the view states and data-driven UI. Next, we will talk about how to adapt our application to SwiftUI using two architectures, two basic solutions, MVVM and MVI. Next, we will talk about the pitfalls in our solution and how it could be optimized using different ways. So let's begin. Apple introduced new SwiftUI framework in WWDC session last year. This was claimed as a super easy, super fast, and super innovative tool to create declarative style programming. There is no need to use auto layout or interface builder at all. Also, it was claimed that there is no need to use UIViewController or UIView. We should use specific structures that implements protocol view, and in body property we should describe all the content of our view and put all subviews in this place. And of course we should use declarative syntax to create our view. The example of the code in the slide will turns into the list of featured elements. It's just like your table view, but we use specific list control. And when the user will tap to any row, there will be navigation to next view with the content of feature element. And we should also use declarative syntax to create specific customization or stylization of our views. For example, this piece of code, it is some text, some label control. Yes, SwiftUI controls are resembled to iOS classic controls. And here we will specify the font settings for this view. So, another main feature of SwiftUI is using view builder declarative constructor for UI. And it is a mechanism of functional builder that was represented in Swift 5.1, and it takes from 1 to 10 elements as elements of array that will be put in some parent container, and there will be some sort of logic. So talking about view builder, these elements will be placed in correct place with some settings of size, preset of paddings, and there is no need to use add subview to put the element. So we only should put element in specific container in specific with specific presets. So this code will be turned into this featured row with vertically placed labels and some image in horizontal stack. So, if though there is no need to use UIViewController, the start point of our application should be described as specific UIViewController, UI hosting controller that takes initializer as a parameter our content view. And this UI hosting controller will be placed as a root controller to window property in our theme delegate. In WWDC 2020, Apple presented new way to create start point of application in declarative style. There is no need to use AppDelegate or ThinkDelegate. Of course, you can use them if you want and if you need, but basically you can create some struct that implements protocol app, and in the body of this app, you will place your specific window and use specific content view as a child. Navigation is also provided in declarative style code. You have destination view as a parameter of your navigation link. It is a main mechanism in SwiftUI to perform navigation just like segue, just like push segue. So you specify destination view and you specify the view that wrapped in navigation link, and in interaction with this specified view will trigger the event of navigation. And if you want your code to work, you should place all your navigation link with all container views in a specific control navigation view that encapsulates UIViewController with all its properties and logic and functionality. But there is some problems. There is no direct access to properties of your navigation controller and no direct access to the stack of views. So a navigation link provides you only going forward navigation type, and you can return to previous screen using only a code in back button embedded in navigation bar. And there is no possibility to create dynamic code for navigation runtimely. And there is no way to return to root view or to specific view. So there is the first problem in SwiftUI. Also, we should talk about its data flow. It is not a sequence of the events anymore. It is just the result of state function. So the event, the user interaction, not changing the some properties of your view directly. It should change the value of specific property with specific modifier, and your view should listen to the changes of this property, and then your view will change some its properties. So such properties are called property wrappers, and there are some kinds of property wrappings depending on this functionality. The state, it is a local scope variable, just like private, your view owns its variable. Binding, it is just like sharing by reference, just like weak sharing reference, and you will put your element, your variable to next view, but your first view holds, and second view holds only the link to your view, and then if it will change the value of your variable, it will affect the original variable. Next one is environment object. It is to sharing between views. And you also could use combine API to listen to changes of these properties. For example, mostly it is recommended to use a model of your properties, and your model will implement observable object, and every property in this model will have published modifier, and your view will listen to changes of this model and will receive from these published properties new values to its properties. The mechanism is you have some property wrapper. For example, you have variable, and from the value of this variable depends the source of your image. For example, you have some view with navigation bar, and your navigation bar have some button with some image in this button. And when you click on the button, you will change the property, and this change will cause the rebuilding of your whole view, and then your image will get new source for its image. So you will get two states depending on one variable. And this is how data-driven data flow works. So let's summarize what we have. There is whole SwiftUI basics. So we have view instead of UIViewController and UIView. We have data-driven data flow instead of event-driven. And we should use declarative style programming. Now let's take a look to real application and how can we adapt it to SwiftUI. So we have classic iOS application. It has three screens, a list, element, and some kinds of search. So this application uses OpenAPI MobileOptimized, and every screen is a separated module with MVS architecture, it has view, it has some business logic, and it has some intermediate logic that receives signals from your view, make some requests to your business logic, and then returns the values to your view. So you have also a business logic. It will be common business logic for whole your project, and we will specify some service to make requests to common local storage and to common network service. Just like classic realization for any business logic in iOS application. What we should do? Apple suggests us to use a combined API to provide interaction between view and between model. So what is model in data-driven data flow? It is a state and it is also business logic. It implements observable object protocol and binds to view as observed object. So we should use MVVM architecture. It is a default solution that was presented in SwiftUI 2019, and we should do some changes in our modules. So we have view, we still have view, but we will use view written declarative, and we will get model as a state and intermediate logic, and model will do some requests to our services, deliver data, and send its changes to our view. Not so hard. And we will put the link to our view model in our view, and we should call the functionality of this model from specific methods of lifecycle of our view. For example, on appear, it's just like view will appear in UIViewController. So now we should change event-driven data flow to data-driven data flow. There are three possible solutions. We could change all the code to use combined API. We could wrap all our existing functionality in combined API, or we could not to change anything and we just will call the request in observable object model and make some callbacks to our view. First way, what is combined API? It looks like reactive API. Yes, it is declarative API created by Apple, and it is resembled to reactive API. It is used for asynchronous logic. There is some publishers, subjects, and we can use a cancelable instead of disposable, just like in reactive API. And some methods have same naming. So in iOS 13 and 14, there is possibility for many components to provide us a logic of default publishers of these components, for example, for URL session delegates, etc. And then when we will get the result of our work, we will assign it to publish property. Another way, we can use our default logic and use some sort of subject to create signal, and when we will get new value of this property, we will call send methods with new value. Not so hard, it looks really easy, but we have to change everything. We have lack of time, so let's take a look to the second way. We can provide the same logic, but we should wrap it in combined API. We could use future promises API in this way. For example, we will call our default method, and the completion handler, we will send promise with success result if everything is okay, or failure result if there is any error. And we will get it in our view model, and in completion handler of this method, we will put the result to our published variable. Looks not so hard, but there is one question. If we get the value in completion handler and we will put it into published variable in completion handler, so it means that we can do nothing with our default code, and we will put all main logic only in completion handler. So we will put the result of the functionality in our completion handler, and the view model will do the callback to our view automatically. And I prefer to use this way to adapt my business logic. So you have 3 ways. You can select any way you want, but it depends on your time and your plans. I don't plan to change anything. So now take a look what we have got. We have got a MVVM application, but our view model looks to be a little bit overloaded with some redundant code. Yes, it is classic tendency for any MVVM application, because view model, it is not only the state, it is an intermediate logic that interacts with the view and business logic, and it is also some code to present our values for our views. So there is another problem. It is not connected with MVVM, but it is a common problem for SwiftUI. View is a structure, so there is no inheritance at all, and we have to use redundant code. For example, we have some logic for showing errors, for showing loadings, and etc. And also we have some managing navigation troubles with navigation links. We will optimize this code later. So at first, let's make our MVVM lighter. This year, Apple presented another default architecture solution for SwiftUI. It is MVI Redux. So our action should the action of our user, the user interactions, perform some action. It creates some action that will change the state of our application. It will create the state of our application, and then the state will update our view. And for example, maybe it means that our view model split into the state and to the intent that will change this state. And it looks like this. So we have on the left side on the VVM we have view model, and now we have intent that will create our state, and view will call this intent. So at first time it looks like this, and it means, for example, that we should, instead of our view model, we have to have some state component and some intent component, and this intent component will call our business logic and then update our states, and state will update our view. So next, our view model is only for keeping the properties. It is only for holding the state of our view and for getting some updates from business logic. So in our list view, we will call not the model, we will call some logic that will perform for us our model. But what about intent? What about intent? What place takes intent in this schema? Is it an action or it is an intermediate logic? Correctly, intent is an action type to request state. It is not intermediate logic. We should have specific component for our intermediate logic, and then in this processor, we will call this processor. You can call it any way you want. This processor will receive specific intent, and depending on the type of this intent, it will provide some state. So here is some solution. It is not claimed to be a silver bullet. And intent is the action type to request specific state. So we could use a num for our action types, and now our processor will perform some action depending on these types. For example, if we will put load movies intent type, it will call the logic for requesting loading movies. Now, when we will get the result, we should put it back to our view. I prefer to use a link for callbacking from our processor. So processor will keep the link to my view, and then I will receive my updates. So next, I will call the logic of processor from my view. I also have a link to the processor, and then I will call it in onAppear lifecycle method. And when I will receive, I will put all my data to my model. It's a good idea for all models to implement common protocol to make some common logic at all. So let's summarize. Today, at the moment, we have state of view and separated from intermediate logic. And this intermediate logic is also separate from action types. So in this moment, MVI looks more lightweight than MVVM is. So what we still have? We still have a lot of redundant code because of supported inheritance of view. And we also have a lot of abstraction because of unsupported inheritance. And we still have routing and configuration problems. Let's make some optimization to our code. Yes. What is the redundant code? Duplication. It is styles, common UI elements, alerts, and common logic. We cannot use inheritance, but we can use composition of views. It's a real good solution in our case. So we will put all our child views. Yes, we will perform our views as a child to some specific containers. And we will use these containers instead of base parent views. Every container will have its specific model, and every child will have its specific model. So we should make some linking between these elements. We will put our child view as a content in body of our container view. Here also we will place all common logic. And all these common elements will depend from properties of our container model. And when we will put our child view as a parameter in initializator of our container view, we will hold the reference to the container in view model of our view. So yes, it is a very good idea for all our models to implement one common protocol to hold the reference to container and to perform some common logic. Next one, when we will get new state in our view model, we will call with the reference to container the logic in container. For example, if we should show that there is some loading in our application, we will call show loading method in our listener. Yes, it should do many actions. So let's make some configuration. To provide easy way to create a setup our screen model, we should use some configurator, and it will takes the type of our view, create some specific configurator for it, and then turn our view to any view. It is a common type as any object to view, but for view. So we will do this way. In a specific method, in specific configurator, we will perform initialization of our view with all its elements and putting it together, and then we will return our view. So, and we still have problem with navigation and routing. How can we make any solution to this? How can we provide any solution to this? So, by default, we have navigation link, and this navigation link will have our complicated logic as a destination view. So it's in our case it looks not so hard. There is not too much code, but if we have to put different types of views, we should have different navigation links, and we will provide all these navigation links at the same moment in our code. So it looks really heavy, And every link should have its own state variable, so we should manage all these variables. It's not so good. Moreover, navigation link is not lazy. Even if you have only one type of element, for example, you have one navigation link because it is list and you have a cycle, and in cycle you create navigation link for every row is displayed on your screen. But at this moment you create every view for your element, and for every view, yes, you create not only a view for row, but you create the view for any item view with all its stuff, and all these models of these elements created at the same time, and if they perform any logic in initialization moment, you could have a collision, and of course it's bad performance at all. So you could use some sort of fabric, but it is negligible benefits because of lack of abstraction. You still have to use a lot of code. What should be done? We could make some navigator, and we will call our configurator from navigator. So there is two ways to create navigator. First one, we can wrap all our views in hosting controller, and as UI hosting controller is UIViewController, we can use UIViewController based navigator, and we will put a view in UI hosting controller in our configurator. We will make some changes in our configurator, and we will call our specific configurator from navigator. And second way, we could use only SwiftUI logic, no UI kit, and we should create some custom stack view to manage the sequence of our view. For example, we will have some container navigation view, and in this view we will put all our views, and not in the same time, but depending the property of our view model. Yes, dependent of the view model of this container view. And if it is a start of our navigation, we will show in body only top view. But another way, we should show the view from the top of the stack. So it is recommended solution because it's only SwiftUI code. So now we will have totally adapted our application. And let's summarize. So, SwiftUI provides a functionality to create an app with complicated architecture. Yes, it is sophisticated with a way of optimization, but we can do optimization by many variable ways. And MVI in SwiftUI looks more lightweight than MVVM is, and intent could be mixed with intermediate logic. It is a main problem. If you decide what is the role of intent in your architecture, it will be more simpler. And of course, it's risk to create too complicated, sophisticated solution than in classic iOS application. So that's all. What also we can say. I'll be waiting for SwiftUI 3.0, and I believe that Apple will provide more complicated and more convenient solution to create applications without any pitfalls. So let's be waiting for the next WWDC. Some useful links, and thanks for watching.